Hey there, I'm back. Long time no see. I got an encouraging comment from someone on YouTube saying, "Hey, are you going to keep doing this?" And I'd been thinking about it already for a few days, so thank you for the encouraging comment, whoever you are. Uh, but it gave me the kick I needed, and I thought I'd try to jump back into this. Maybe try to do one a week or whatever happens, but at least not the long period of time that it took me to get to this one. So I've got my party size bag of Starburst for dinner, and I'm ready to make a video. So to get back into the swing of things, I thought I'd go over what I'd been working on, because while I have not been making videos about Natalie, I've still been doing commits and writing code. And so I thought I'd go over some of the big changes since last time. Here, December 17th was my last commit on video, and just thought I'd go over some changes. Some of them are pretty huge and pretty exciting. So first one, right after the last video I made, I fixed a really bad bug. I don't know how I'd gotten as far as I had without fixing this, but essentially was not building the environment hierarchy correctly when calling methods and blocks and such. And I found that out when I was okay. Yeah, I don't want to grep. There we go. I was trying to catch an exception, and it would just be stuck in an endless loop. So I added this little counter here. If the counter depth when raising an exception is more than 10,000, then we have a serious problem. And so I just added an insertion here, and that helped me figure out that what I needed to do was build a new environment every time I call a function. And in hindsight, that seems very obvious, but somehow I'd missed it. I'd gotten very far in the language for several months without actually fixing that. And when I was Googling this, I learned a new term. I thought I'd share it with you. The stack that Natalie is currently using is called a spaghetti stack because it's objects that just point to each other, and it's not a linear stack like C would use, and that has made it a lot easier to get as far as we have without having to try to mess with stack allocation and doing everything linearly, especially with closures, Ruby blocks and stuff like that. I don't even know how we would do that with a linear stack. So what Natalie uses is a spaghetti stack, and learning that helps me realize that, oh, I needed to build a new environment or a stack frame or whatever you want to call it every time we call a method. So that was a big change, and it's not a lot of code in that commit, but a big change in my understanding of how everything works. A bunch of new specs. This is just more spec stuff. I added an I flag, a capital I, just like Ruby does for load path, so you can set the load path when you're uh, running Natalie code. Added kernel exit, pretty simple stuff. Rewrote some tests. Oh, this was big. Rewrote the Natalie compiler using multiple passes, and this has made understanding the compiler way easier. Whereas before we had one big Ruby class doing all the work, and it was getting a little bit out of hand, a lot out of hand. And now it actually does it in multiple passes, and I have further commits up where I actually ended up using 5 passes. But in this commit, we started out with 3 passes. The first pass just converts the S expressions into new S expressions that resemble C. The second pass converts that to actual C code that's like strings. And then the third pass does variable elimination, unused variables, so that the C compiler doesn't complain about us having unused variables. And so that was huge. Also in this commit, I removed the parser that I've been working on, which was just gross. As you can see from previous videos, it was so hacky, and it was distracting me from focusing on the language semantics. I was spending a lot of time on parsing, and so I ended up using the Ruby parser gem, which is fantastic. And I threw out all of the parsing tests and parser code that I had written before. It was very buggy, and this is way better. I might come back someday and write my own parser if I get ambitious. But my hope is, since the Ruby parser gem is written in Ruby, obviously, and doesn't have any C code, it's just pure Ruby, I hope to get Natalie to the point someday where it can compile the Ruby parser gem, and then yeah, we can just use it like that. So yeah, enough said. Enough said about that. So, a bunch of just miscellaneous stuff, nothing too crazy. Added a proper singleton class. Ruby has, uh, it has class methods, but the way they're defined is actually on a singleton class. And I was cheating before. I had just stuck the methods directly on an object, and that's not how Ruby works. So spent a bunch of time figuring out how Ruby works, how it builds a singleton class for individual objects, and figuring out the hierarchy of how the method resolution works. And that was a fun commit. I wish I had done a video about that, but it would have been a lot of head scratching and a lot of wasted time. Um, and so I started pulling in specs from Ruby Spec, which is obviously specs for Ruby, written in Ruby, and I started pulling those in and trying to fix some of the failures. And I got a few of them. I got and array and alias and some others. And I got them mostly passing. I had to comment out some code, but that's been fun. Implemented some more methods, added alias keyword, fixed some stuff. Yeah, I don't even know what that is. Probably not important. Oh, we fixed how exit works. It actually now raises the system exit error, and then at the top level in the C code, we rescue that and return a proper status code. That was fun. I didn't even know that's how Ruby worked, but doing this commit forced me to learn all that. Don't know what that is. Implemented kernel at exit, and we use that with, let's see, we use that with the spec runner now. Spec, I think it's here. Yeah. So here we do at exit run specs so that I don't have to have this line run specs at the bottom of every file. Now I can just have, the tests like so, and it just runs whenever this file runs because we use the at exit hook, and that was pretty cool to learn about how Ruby does that. And I think it's time for a starburst. You can hear me smack on this while I look through this. Fix some race condition, don't even remember that. Yeah, that's not helpful. Started hash. We now have hash in Natalie, which is pretty cool. It uses the hash map library that I've been using, the MIT license C library that I borrowed, and it works pretty well. So I didn't really have to write all the nitty-gritty details of that. And then I made it maintains insertion order now, just like Ruby hash does. And let's pause for Starburst. Wow, it took a really long time for me to chew that. Really glad I didn't subject you to it. And I'm not even being sponsored by Starburst. Not that they would sponsor this video anyway. More hash stuff, yay. Looking for the big ones. Looking for the big ones here. Yeah, I did block argument and method argument handling so many times and rewrote it 3 or 4 times, so I'm not even going to get into that. Not a fun set of days. Yeah, that's what all this is. Multiple days in a row. Yep, yep, complicated. Yep, I wrote it, then threw it away. Not fun. Um, yep, renamed some stuff. Oh, okay. So this is getting into separating constants and regular variables. I don't know why I didn't do this from the beginning, but I had regular variables and constants stored the same way, which was amazingly stupid. Um, Caused so many pains and headaches um, throughout the whole life of this project. And I didn't realize it until, I guess, January 24th, that was causing me so much trouble. And so I separated out. Now constants are in their own storage, and they're basically a hash map, and they're stored on objects, and as they should be, and they have namespaces and all that. And now variables that separated out variables from constants, which let me do a lot of other things, including, I don't know where the commit is, but I ended up making variable storage much more efficient. It's no longer being stored in a hash map because there's a cost to that. And um, I was using the Fibonacci example code as a sort of benchmark, and the Ruby was able to run that code much faster than Natalie was able to, and that's here, fibnat. So just this, the way this works, it's very recursive, and it builds a very large tree on the stack. And it was very inefficient because I was just using essentially one variable, but the way we were storing and looking those up was very inefficient. So, and now actually just, let's see if I can get this to actually work. Clean build, is this build? Oh, you piece of junk. Okay, let me fix that real quick. Okay, I got that fixed. Some Ruby stuff on this machine I'd forgotten about. But what I was talking about was running. So if I do time Ruby samples Fibonacci, this takes 0.1 seconds or something, 0.1 something. Okay, it's in that range. And then Natalie obviously is going to be slower because it has to compile. And this Fibonacci code, I'm just getting the 25th number in sequence, and how much time did that take? Come on. Okay, so that takes 1.3. If I compile it, how much time does it take? It takes 0.4. Okay. Before I optimized variable storage, this was taking many seconds. I think it was like 100 times slower than Ruby. So now we're within an order of magnitude of Ruby. So we're in the same order of magnitude, I should say. Ruby is 0.1, we're at 0.3 or 0.4 or something like that. And that's without our garbage collector, without any optimization of how we allocate our spaghetti stack, as I love calling it that now. There's no optimization for that. I've done some experiments, and I can make Natalie faster than Ruby if I do those things, which is great. And I've spent almost no time on optimization. So for us to be in the same ballpark as Ruby, which has a whole host of optimizations, and we're compiling to C, so we have so many more optimizations that we will be able to do. When I started working on this in January, getting this sort of benchmark running in the same ballpark as Ruby in terms of speed, I got really discouraged, and I think that's why I stopped making videos, because I thought if I can't make Natalie as fast as Ruby or even close, then this project is doomed. There's no reason to do it, and I should just give up. And so I kind of felt like I should stop making videos, because here I am, a charlatan, right? I can't make this fast enough. Then there's no reason for me to make videos and tell people to do this. So it took me a couple months, I guess, because here, I mean, what day are we on? February 11th. So over a month to get some optimizations in there to make this benchmark run in a speed that I'm not embarrassed by. Um, and there's still lots more to do, but I feel confident now that it can be done, and we have a path forward. So all that to say, um, my I've kind of forgot where I left off, but I was talking about variable storage. So now instead of trying to put variables in a hash map, which is inefficient and unneeded, we put it in a pre-allocated array on the environment. It's pre-allocated because the compiler knows how many variables there are in each stack frame. So it can pre-allocate that. And the further optimization is if the variable, if there's no closure around the variable, if the variable doesn't need to go along with a block or a proc or something like that, if it's just staying within that stack frame, then we don't even need to put it in that array at all. We can just use a C variable and it stays in the C stack frame, and that's even faster. So all that to say, it was a lot of work. Glad I got it figured out. Another optimization I did was instead of allocating a full Natalie object for integers, we used a 63-bit tagged pointer, which is what Ruby does, which is to say we use the space that a pointer, the memory that a pointer itself would take up. And instead of using that as a pointer and pointing to a chunk of memory, we actually just store the integer as 63 bits in that pointer, and we do some shift stuff to make it basically end with a 1 bit, which tells the code later that it's an integer. This code blew my mind a little bit. I didn't know Ruby did this, but it explained why Ruby was so much faster than Natalie at doing that Fibonacci thing, because that's all numbers. And so I started reading about this, and this Stack Overflow answer was super helpful and taught me how that worked. And sure enough, I think that was 10 times faster writing the Fibonacci benchmark once I got this code in, at the expense of making the code a little more complicated. But basically now we just have this macro here. So instead of checking the type as if an object is a pointer to an actual struct, and doing, instead of saying, obj type and then checking if it's an integer or whatever, we now just do nat type obj and all over the place anytime we need to check a type. And what this does is it basically checks to see if that last bit is a 1, then we know it's an integer. Otherwise, it's a struct pointing to an object. And so using this macro kind of hides a lot of the complicated bits there. And then we have another macro, which is nat int value, which extracts the value as an integer. So anyway, that was a lot of fun. Learned a lot there and made Natalie a lot faster. Blah, 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 looking for a big commit. Oh, local variables, that's what I was talking about. We actually have an optimized release build now. Oh, that's the other thing. I didn't even do it as a release build earlier. So I'm just curious, actually. Make clean. I gotta fix this. I don't know where those came from, but it's all in one file or 2 files. I probably did something stupid. Let's do cfib samples fib time fib, and oh yeah, so we cut it in half. So now we're down to 0.2626, and the time for Ruby is 0.19. So we're really close, and we still don't have a garbage collector, still don't have any optimizations around how we allocate memory for our spaghetti stack. Love saying that, spaghetti stack. So that's pretty cool. And how I think I just do this back, make clean, and that's how it switches back. And you'll notice that now we're doing -G for debug symbols, whereas up here we were doing O3, which is highly optimized. So fun stuff. And I'm sorry, this video is kind of boring, I think. I'm not really teaching anything. As I've said in previous videos, these videos are really more for me, for just history of the project, for me to look back and maybe show my grandkids someday if they ever want to see like what coding in 2020 was like, at least for me. Um, oh, I don't know if I showed the spec library, but this thing it's gotten a lot bigger since my last video, a lot better. Um, we now have different contexts and you can nest those as much as you want. And we have where you can skip tests with, if you put an X in front of a test, it will skip it. We have before blocks that run before a test or a set of tests within a context. We have different matchers. So, oh, and the syntax changed. So now it's, let's see if I can find a test here. Alias. Oh, that's probably not. Test, Natalie, loop test. What does this one look like? Yeah, so now we do x dot should equals 3. And so that uses the equals matcher, equal in the matcher here. And then we have be nil. So you can say something should be nil. So like this would be like this. Be kind of, so you can do be kind of array or whatever. Equal raise. Oh, and we also have raise error. So we could say raise yo should raise error standard error, like that. That's been super cool, helpful. And then, like I said earlier, we have the specs run automatically at exit. And then we have a whole bunch more helpful output when specs fail. So this is the most complicated Natalie code in existence right here, if you don't count Ruby code itself. But this is the most complicated code we've written so far. So pretty exciting. And I think we're getting caught up with reality. We're at February 8th. Added some more methods. Oh, I added file support. So now you can read and write files. Added the IO object like Ruby has. So here we have IO rewind, IO seek. You can open a file as read plus, write plus, append plus, just like Ruby. This is just me reorganizing some stuff, and we're up to real time. So 23-minute video that if you watched the whole way, then congratulations. Time for a starburst. And that gives me caught up, so I hopefully can make another video now of actually how to do something. I'm not even sure what to work on next. I'll come up with something interesting. Reading, writing files was really cool. That gives us access to the outside world. Natalie still doesn't know how to do incoming arguments, and so maybe we'll do that. argv, and then also standard in. Natalie does not have support for standard in yet, and I'm pretty sure that the way I'm doing standard out is actually wrong too. Basic object. Is this where puts is? No, it's on object. Where is puts? Oh, it's in kernel. Yeah, so puts right now is basically just calling printf, but in Ruby, I'm pretty sure you can point standard out somewhere else, and this needs to respect that. And now that we have an IO object, yeah, now we have this object. I think we can wire all that up so that puts and those sort of methods, they talk to standard out. And so we would need, we'll basically have a standard out and a standard in, these globals. need to be wired up. So those are two big projects that I'll be working on next, and can't wait to get started. And thanks for watching. So I'll see you next time.